Okay, so let's take a look at question number 36 here in section 2.1 on determinants. And this is a show that. So we want to show that this formula works for every 2 by 2 matrix A. Formula says that the determinant of A, okay, is equal to 1/2 times what? These vertical lines mean what? The determinant of, and you have another matrix, and that matrix there is also 2 by 2, and its entries are formed by, some of them, by the trace of either A or A squared. So basically the way to do this problem is simply to come up with an arbitrary matrix A that's 2 by 2, evaluate this expression over here on the right and show that it's equal to the determinant of A. And that's what we're going to do. So we start with defining the 2 by 2 matrix. It has to be arbitrary. So I'm going to use just the letters A, B, C, D. If you want to do A11, A12, A21, A22, like we do with the double subscript notation, that's fine as well. But each entry must be unique. So you can't force it to have any sort of features like symmetric or anything else. So this is arbitrary. Okay. But once we have that, the trace, remember, is the sum of the main diagonal elements. So the trace is just A plus D. Remember, the trace is a real number. The determinant is also a real number, and we know now from this section the determinant of this matrix is A times D minus B times C. All right. Now, I also in that formula needed the trace of, in addition to trace of A, I needed the trace of A squared. So I need to compute A squared first. So A squared is just A times A. 2 by 2 times a 2 by 2 gives me a 2 by 2. This first row, first column entry is determined by taking the first row of A times the first column of A. So A times A is A squared, B times C is BC. Add them together. This entry is the first row of A times the second column of A times B, B times D, and so on. Second row, first column gives me this entry, and second row CD times second column BD, of course, again, dot product, I get BC plus D squared. So the trace of A squared is going to be this entry plus this entry, the main diagonal entries, which is this, and the BCs I can combine to 2BC. Okay. So now once we have that, let's plug these values into our expression on the right, which was 1/2 the determinant of this 2 by 2 matrix. I'm going to replace trace of A with A plus D, the trace of A squared with this expression. And so here is my determinant. How do I find the determinant? It's the product of these two, which is A plus D squared, minus 1 times this. So it's just minus this whole thing. Still have this 1/2 out here. Now it's just algebra. Foil this out. I get A squared plus 2AD plus D squared. Distribute the negative sign through all these terms. You'll notice the A squareds go away. The D squared minus D squared is 0. I'm just left with 2AD minus 2BC. If I now distribute that 1/2, I get AD minus BC. And what is AD minus BC? That is the determinant of A, as we stated above. So there is the way to show that this formula works for any 2 by 2 matrix.